Hello, welcome back to this financial series of videos. Today we're going to be looking at compound interest, where interest is compounding monthly or quarterly or 6 monthly. Whereas last video we looked at it compounding yearly. And we're going to be using the compound interest formula to calculate compound interest and final values of an investment or loan. And we are going to determine which is the best investment plan given a simple interest rate, a compound interest rate compounding yearly, and a compound interest rate with weekly rests. Okay, so comparing which is the best investment plan. And you might want to pause the video and attempt these questions before you look at how I approach them. So there's actually 6 questions. So there's a few on this page and a few on this page. So they'll take a bit to get through. Let's have a look at our formulas. So the same old compounding interest formula, except I and N are calculated a little bit differently when the compounding period is less than a year. So if you get an exam question and it says interest compounding daily or weekly or monthly, fortnightly, every 6 months, you're going to calculate I a little bit differently and N a little bit differently. And we're going to see how that is done. That's the only difference. I and N are a little bit different. A bank offers a loan with a compound interest rate of 5.8% per year with monthly rests. Determine the monthly interest rate for this loan. Okay, easy enough. I won't get too caught up in these formulas just yet. Let's have a look. So we've been given the interest rate is 5.8% per year, and they want that as per month. So to get that as per month, there's 12 months in a year, right? So we're going to be dividing by 12. That's all that we do for this first question. 5.8 divided by 12, and it's 0.483%. So if you're ever asked to calculate an interest rate, you want to answer as a percentage. So we didn't even have to convert to a decimal yet here. So this is it. Monthly interest rate. Part B. If $10,000 is borrowed, $10,000 is borrowed. That means that's the principal. Let's write it down. For a period of 6 months, how much must be paid back to the bank? So here's where it's a little bit different. In A, they asked us to calculate the monthly interest rate per month. As in units of per month. So we are going to use that interest rate. We're going to use that 0.483% per month as calculated in part A. And we are going to borrow it for a period of 6 months. So we'll convert this to a decimal soon. I just want to write this straight down. N is 6 months. Let me write that straight down. Leave a bit of room to calculate I as a decimal. You want these to be the same time units. That's the key to these sort of questions. You don't really have to memorize too much if you just get them in the same time units. But anyway, we know that I needs to be as a decimal. I as a decimal, you divide it by 100. Okay, that will be 0.00483 per month. How much must be paid back to the bank? How much does it amount to is what they're asking. Now we know it's compound interest, so we know the formula for that. Let's move that up a bit. P is 10,000. I is our monthly interest rate as a decimal. N is 6. Put that into your calculator. 10,000 times 1 plus 483 to the 6. $10,293.32. That's our part B answered. So if $10,000 is borrowed, after a period of 6 months, they're going to have a little bit of interest to pay. $293 interest. Now, what are they saying? Let's do C over here. If $35,000 is borrowed, okay, the principal's changed. For a period of 3 years, again, we're using that interest rate per month. Therefore, we need our time period to be number of months. That's what I guess this bit is getting at. So this time, we've got 3 years times 12 months per year. 12 months per year. As you can see, the years cancel, but that might be taking it too far. Don't want to confuse you. 3 12s are 36. Include your units after. How much must be paid back to the bank? Well, we've got our little I, our monthly interest rate. Well, that looks a bit weird. Oh. The amount to be paid back to the bank. We've got P, we've got I, we've got N. 1 plus 0.00483 to the 36 months. I'm interested to see what this will be. So 35,000, maybe they're buying a brand new car or something. 1 plus 0.00483 to the power of 36. That gets me $41,629.52. That's how much they must pay back to the bank if they're borrowing $35,000. So about $6,000 in interest. $6,000 down the drain to the banks. Next question. A bank will pay compound interest. May as well just write it down as we go. We know that's the compound interest formula. At the rate of 3.9% per year. 3.9% per year. With fortnightly rests. Okay. Now we can do a little thing here. This is what some people memorize. So K is the number of rests. The number of compounding periods per year. Now, how many fortnights are there in a year? That's correct. There's 26 fortnights per year. So that means that K will be 26. I'm just going to say fortnights per year. That might help us soon. What is the fortnightly interest rate for this investment? The fortnightly interest rate might just, oh no, I'll leave it here. So if we, let's have our A here. Fortnightly, you're dividing it up. You're dividing up this interest rate into all the fortnights in a year. So I'm going to say divide by 26. And remember, we want to answer our interest rate as a percentage. If it's actually asking what's the interest rate, have it as a percentage. But within calculations, we need it as a decimal. We haven't got to that point yet, so don't worry about it. So I'm doing in my calculator 3.9 divide 26. And that will give me 0.15% per fortnight. Okay, and while I'm here, I may as well convert that to a decimal because I'll need it soon, it appears. So we put a 0 under that hump. There's 2 zeros here. And per fortnight. We've answered part A. Nice. B. Let's do B over here. If $4,000 is invested, 4,000 invested means that initial value, the principal, for a period of 5 years. So we've got our time value now. In order to get N this time, we need the number of fortnights in 5 years, and that's where that magic K value comes in. The number of fortnights in 5 years will be 26 times your actual number of years. So 26 times 5. Give you the number of fortnights in 5 years. Always include your units after. And then they're saying, what's the final value of the investment? They have lots of words for this A. Amount, balance, final value. That's all I can think of right now. A equals P times 1 plus I to the N. We've got our P. We've got our I as per fortnight, and we've got our N in fortnights. Substitute. Must have that as a decimal interest rate per fortnight. 130. 4,000. 1 plus 0.0015 to the 130. $4,860.53. Okay, after 5 years, $4,000 invested will actually get you $860.53 in interest, which is nice. You could buy a fair few groceries for that. Few weeks, few dinners out. How much interest will be earned on this investment after 5 years? Well, I just sort of told you the answer, but officially calculating it, the interest earned on the investment. Well, we can just derive it from this if we want. The amount is your principal plus your interest. If we want that interest on its own, we take the P to the other side. So taking P from both sides. We've got $4,860.53, take 4,000. So after doing many of these, you'll immediately see the interest. And I have done many of these questions, so hopefully it's actually right, because otherwise it won't look like I've done these questions. $860.53. And don't forget your units. Okay. So that's the interest earned after 5 years. May as well go to the next question. We got some questions to get through. Take a break if you need. You've got all the time in the world, unless it's the night before your exam. In that case, I'm sorry, you're probably not going to make it. Okay. Quinn would like to invest some money in an account that earns compound interest at the... Okay, let's... As we go. Compound interest, I know something for that. At the rate of 7.6% per year. I is 7.6% per year. With weekly compounds, I can write down my magic K value. with weekly compounds. So I asked myself, how many weeks are there in a year? There's 52 weeks in a year. This can be handy. If we're finding interest rate, we divide by that 52. And our n also has to be in weeks, so we'll times the number of years by that. But let's actually see what the question's asking. If Quinn would like their investment to grow to $20,000 after 5 years, how much should they invest? So it's a bit of a different one. We're usually calculating A, but this time we know how much it amounts to. We know how much it wants to grow to, that future value. And that future value, come right here. They want it to grow to a future value of $20,000. After 5 years, so that means if it's compounding weekly, after 5 years, we're going to have K times T, our magic number, 52 weeks times 5 weeks per year times 5 years will give us our total number of weeks in 5 years. Hopefully I haven't annoyed you too much by repeating myself. 260 weeks. A lot of weeks. A lot of weeks in 5 years. They're asking how much should they invest? How much should they invest initially? At the start. The present value, which is sometimes what it's called. This time we're actually finding P. I'll write my compound interest formula over here. Now think about, so you can either substitute and then rearrange, or yeah, we're going to do that. Let's substitute our knowns. We've got A is 20,000. P, we're actually trying to find P. Well, we need this as per week. That's where our little magic formula comes in. Divide by 100 to get as a decimal. And then on that denominator, we're also going to divide by the magic K value. That's how we can do it all in one go. And this is going to give us the interest rate as a decimal per week. And we need those to match up. Those time units. 7.6 divide bracket 100 times 52. Now keep it to lots of significant figures. 0.00146154. I do it to a lot, and then I round at the end. Because I'm paranoid. That's fine. 0.00146154 to the power of 260 weeks. Now we need P. Okay, we're going to divide both sides by that. Okay, we're going to go 20,000. Actually, I'll write it on a new line. 20,000 equals P. We're dividing both sides by this big old decimal. 6154. 146154, yep. 260. That's how we rearrange, I guess, because P is being multiplied. If it's written next to the bracket, it's being multiplied by this big bracketed thing. Therefore, we divide both sides in order to cancel that big bracket exponent thing. We're dividing both sides by it. That's all I'm doing. Put it in your calculator. 20,000 divided by 1 plus 0.0014. Oops. 146154. All the numbers start to look and sound the same. And let's raise that to the power of 260 on that denominator. Oh, 260. Carefully entering those numbers. Now I hope this is right. I initially thought that it was wrong, but it's all good because we're finding the principal. So it should be less than the amount. $13,681.02. So you can round once you get to the dollars and cents part, but that interest rate should be to as many significant figures as possible. So this is how much Quinn should invest. If she wants to have $20,000 after 5 years, she should invest around nearly $14,000. So it's nice to save your money and get some money from it. All right. Next one. You might want to take a break if you haven't already. I would really suggest it. Let's do this. And I think it's probably time to just, because that looks like a big block of info. So sometimes I just like to put a square down, a rectangle down, and so it doesn't look too hectic. 3 years ago, an apartment was for sale at $350,000. So getting into some big money now. That's kind of exciting. Tony had been saving and had the money to buy the apartment, but missed out at the auction. This is kind of getting annoying now, this rectangle, because of that thing. You know what? We're not doing the rectangle anymore. We're pointing. And we'll underline as we go. And great. It's disconnected. Okay. It's all happening. An apartment was for sale at $350,000. Tony had been saving and had the money to buy the apartment, but missed out at the auction. 3 years later, the apartment is again for sale, but now at $425,000. Tony will now need to borrow the amount that is equivalent to the increase in price. How much interest will she have to pay on a loan compounded quarterly over 5 years? Compounded quarterly over 5 years with an annual rate of 13%. Let us go. I saw this as a exam question recently in year 11 general. I thought it was a really good question. I learned some things. About myself. All right. Well, about Tony anyway. Let's do this. The key bit here, you might need to read it a few times like I did. We're looking at this second half of it. Tony will now need to borrow the amount that is... Sorry, I did not just burp then. Yes, I did. She'll now need to borrow the amount that is equivalent to the increase in price. That's what we are interested in. We're going to... Let's have a look. So she needs to borrow that amount. So the principal equals the increase in price. Now, what is that increase in price? Feel free to pause the video and reread it because it takes some time. So 3 years ago, the apartment was for sale for $350,000. But 3 years later, it's set for sale at $425,000. So it's just that difference. That's how much she is going to need to borrow. Like, she had the money for it, but then it increased in price. So sadly, she's got to rely on the banks. $425,000, take $350,000, $75,000. That's how much she's got to borrow, that initial value, the principal. So we've dealt with that information in the beginning. It's nice. How much interest will she have to pay? Interest, that's what we're calculating. On a loan compounded quarterly. That's our magic value here, our K value. If it's compounded quarterly, I ask myself, how many quarters are there in a year? 4. That's our magic number. 4 quarters per year. over 5 years. N, well, we need our N to be in quarters too. So we've got 5 years times 4 quarters a year, 20 quarters. That's the number we want to use. With an annual rate of 13%. Annual means yearly. Even though they say rate, they assume we know what we're talking about. It's interest rate. Annual rate, 13% per year. And if we come back here, that's what we're after. We convert to a decimal by dividing by 100, and we convert to an interest rate per quarter by dividing by that magic K value. Let's do it. I equals 13 divided by 100 to get to a decimal. We need it as, well, I might just put a box around that K value because it's important for here and here. We need our interest rate as per quarter if we're going to substitute it into that formula. 13 divided by 100 times 4. Interest rate is a decimal per quarter. Now we're looking pretty good. We're looking pretty good. Now some people get stuck at this step because they're like, hang on, what? How on earth can I get to I? Like I know that I is A take P, but like, and I know P, don't know A. How can I possibly find A? Well, we know that it's compound interest. We know that we can go to our formula sheet and find that immediately. A equals P times 1 plus I to the n. That's how we're going to find A. And then we can calculate I. So I'm just going to say step 1, find A. Step 2, use this formula. These are your 2 formulas you want to work with together. Let's do this. Let's find A. From our data table, P is 75,000. I per quarter as a decimal. N as the number of quarters, 20. 75,000 times 1 plus 0.0325 to the power of 20. $142,187.84. That's a pretty crazy number. So if she's borrowing $75,000, like she's having to pay back almost double to the bank. Sorry, I had to check then. After 5 years. So they can really push up those interest rates sometimes. But anyway, let's answer the question. How much interest? That was our initial. What we need to find. How much interest will she have to pay? So we've found our step 1 now. Now let's use that A to find our capital I. Okay. 142,187.84. Take our initial principal, 75,000. 142,187.84. Take 75,000. It's a lot of interest to pay back. $67,187.84. I don't have that much money. I don't know if they even, I don't know how people do it. I don't know. That's the answer to that one. And what have we got? 2 more questions to go. This one's a little bit different. I think it will pull everything together nicely though. Suppose that you have $20,000 to invest and there are 3 alternative plans for investment. Plan A offers 5.5% per year simple interest. Plan B offers 5.2% per year compound interest. Plan C offers 5% per year compound interest, compounding weekly. Calculate the interest earned by each plan for 7 years. Which is the best plan? How do you want to invest your money? Let's do this. Interest earned by each plan. Let's do plan A first. The principal, $20,000. Simple interest, might just write that down straight away. Simple interest, we've got interest equals PIN, which will be on your formula sheet. 5.5% per year. So I is 5.5% per year. Remember, we need it as a decimal. Divide it by 100. 0.055. And interest earned by each plan for 7 years. N equals 7 years. We have. This is years, this is years. Looking good. Now, simple interest is nice because we can find the interest straight away in one step. Interest is P, which is 20,000, times interest rate as a decimal, times N, which is 7 years. 20,000 times 0.055 times 7. 7,700 in your bank account after 7 years. If you go with that simple interest plan, just call it plan A. Okay. Plan B. 5.2% per year compound interest. Let's move this over a bit. Again, P is 20,000. We know that our compound interest formula is A equals P times 1 plus I to the N. Our interest rate is different this time. Interest rate is 5.2% per year. And I assume it's compounding yearly for this one because it doesn't say otherwise. Whereas in plan C, it says compounding weekly. So we've got per year. So it's as simple as dividing that by 100 to get it as a decimal. 0.052 per year. N is 7 years. Remember, compound interest is a couple of steps. We find that A value first. A equals P, 20,000, times 1 plus 0.052, yep, to the 7. 20,000. We're nearly done, guys. 1 plus 0.052 to the 7. Now that seems a bit intense. Have I done something wrong? Why is that so much? 20,000. What's going on? Don't worry, I just had a mini freak out, but that's what will happen half an hour into recording. We're calculating A. So that's why the number's so big. It's what it amounts to. And then after this, we find the interest. So it's all good. $28,519.40. Now, so we started with 20,000. Makes sense that A would be more than that. I equals amount take the principal. Your interest is your amount take the principal. 28,519 take 20,000. And I think it's gonna, I don't have confidence in myself, but I feel like it's gonna be that. I still chuck it in my calculator. 519.40. Take 20,000. And I should have had more confidence because yes, it is right. So, plan B. Plan A is that. Plan B is that. So plan B is slightly higher with compound interest as expected. Let's keep going. Plan C. Plan C. Again, principal 20,000. Okay. Getting fatigued, aren't I? If you haven't paused the video, you should definitely, because this could be the worst form of torture. All right. Is any form of torture good? I don't know. P is 20,000. Compound interest. We know a formula for that. We stay motivated. It's fine. We've got to this point in the exam. We're tired, but we know this and we come to shine. Now, this is our fun one that we've been practicing this session, compounding weekly. We have a magic K value then. That's what the compounding weekly means. I asked myself, how many weeks in a year? There's 52. 52 weeks per year. You need that. It's going to help you. So principal I is going to be 5 divided by that 100 to get it as a decimal. Also divide by the 52 to get it as weekly compounding interest rate as a decimal. 5 divide bracket 100 times 52. And we go to 0.00096154. A lot of decimals, okay? It's important because it's compounding over years and it all accumulates if you round too soon. PIN. Oh, so that I was the interest rate as a decimal. Whoop. Per week. N, we need the number of weeks in 7 years. Magic K value. 7 times 52. 364 weeks in 7 years. Keep going. Let's find A. A is P, 20,000, times 1 plus I, 0.00096,154 as a robot to the power of 364. Don't forget all those zeros when you input to your calculator. 20,000 times 1 plus 0.00096,154 to the power of 364. $28,376.59. Now, initially, I really thought that that this plan C, because it was compounding weekly, would give us more, but more than anything else. But actually, it's looking like plan B will win. But let's just finish it off. A take P, the interest, we've got our amount, 28,376.59, take 20,000 equals. Look, I'm going to trust myself and say $8,376.59 without putting it in a calculator. Wow. Now that's plan C. Then, as expected, they are asking which is the best plan. the best plan for something that you invest is going to give you the most interest. Whereas the best plan for something that you loan is going to make you pay the least interest. But we're investing, so we want the one that will give us the most interest. Plan B is the highest interest. Not that. So you say plan B because highest interest earned. And if you can stick in there, all right, it is 40 minutes in now. This is the last question, and this will prepare you for the exam, provided you practice. Go to your textbook and practice, and come back to this video and practice, and then look at what I've done and practice again. Let's go. Last question. Determine the annual percentage interest rate. So that's the question. We need percent per year. For an investment of $50,000, an investment of $50,000 is that initial value invested, the principal. Earning compound interest. I know that I have a formula for that. Write it straight down. That compounds monthly. Well, compounding anything other than yearly has a magic K value. How many months are there in a year? There's 12. 12. And with a future value of this much after 4 years. A future value. Okay. Yeah, what am I saying? Yeah, okay. Sorry, I really lost it there. A future value means what it's amounting to. So we're actually given A. Sometimes I get confused when we're given A, if you can't tell. $63,828.57, because we're usually calculating A. After 4 years. N is 4 years, but we want it as months, right? We want that as months if we're going to be using our calculation. So I'm going to multiply by that K value. 12 months per year. That means that 4 12s are 48 months. Now I've forgotten the question. Oh yeah, we need to calculate it as a percent per year. Now let's do it. So what the answer that we get out will give us a decimal interest rate per month. So at the end, it's good to note that. So we will have a decimal per month, and we need to get that to a percent per year. So this time we're going to be timesing it by 100. And then we're going to be timesing it by 12. That's from this thing. So do you get I as a decimal, you divide it before by that K value in the 100. But to get it back, because the interest rate's always given as a percentage. So we need to find it as calculate it, get an answer out as a percentage. Can you tell I'm getting fatigued? Let's use our formula and finish this off so we can all eat dinner. We've got our data table. A is this much. $63,828.57 equals our principal, 50,000, times 1 plus I to the 48. How to get to that I. It looks hectic, but it's fine. We need to get to it eventually. It's all right. First of all, we're going to keep all this bracketed term together. Just forget about that bit. Let's get rid of the 50,000. It's being multiplied by that bracket. We're going to divide both sides. Maybe we get a different color or something. Oh, that won't do. We're going to divide both sides by that 50,000. It's going to cancel. Let's do that side in our calculator. $63,828.57. Divide 50,000. 1.27. Leaves us with that, which looks, slightly better. Still a bit weird though. Now, to undo an exponent, a lot of students get scared at this step. I mean, I'm a little bit scared now, but it's fine. To undo a square, right? So, like, say for instance, you had a squared equals, why not? Let's do a perfect square number. A squared equals 16. To get rid of that squared sign, you can do the square root of 16, right? And that's also the same as 16 to the power of a 1 on 2. You do that reciprocal of that power. If you try that in your calculator, 16 to the power of a half, you will get the same answer. You'll get 4. So what I mean is, let's keep that as a little thing to remember. I don't know, over here somewhere. Oh, I don't know, I can't make up my mind. If we want to undo it, I'm going to say 1.27 to the power of 1 on 48. That's going to undo it to the power of the reciprocal of that power. And then we can just remove those brackets, right? They're not needed. And let's do that. Just move that. Do that and you calculate 1.27 to the power of 1 on 48. Now that gives me 1.0049919 1 plus I. Now, how do I get I on its own? 1 is being added to it, so I'm going to subtract 1 from both sides, and that's going to get rid of that 1. Okay, so even though I could do this one in my head, I'm not doing it. 1.0049919, take 1. Like, I don't even have to do it in my head. I can just look at it without the 1, but it's fine. And that's our I. But remember, that's as a decimal. We want, that's as a decimal per month. We want it as an annual percentage interest rate. So that's where our little note above came in handy. Annual percentage interest rate. This was per month. If I want to convert that to a percentage, I'm going to times it by 100. And if I want it per year, I've got to times it by 12. That's all it's saying. So I'll just write it out here. And into our calculator we go. 0.0049919 times 100 times 12. 5.99% per year. And that seems like a reasonable interest rate, right? If you got a really weird annual interest rate. So your annual interest rate is, I haven't gotten any questions that were, less than 1% and more than 20%. If it lies between there per year, I think you're good. But don't quote me on that, maybe. That seems reasonable. I is about 6% per year. I'm going to leave it there before you cry. But actually, I'm not. This is the summary if you want to write this down. Simple interest, compound interest compounded annually, compound interest compounded K times per year, that magic K value. All right. Have a lovely, lovely night. Good night.